For today's lesson, our focus standard comes from Grade 7, Statistics and Probability, Standard 6. Predict the approximate relative frequency given the probability by observing its long-run relative frequency. Today's topic comes from our probability unit and is titled Predicting Results. Our essential question is, how can we use theoretical probability to predict expected outcomes, also known as results? Please take a moment, pausing the video if you need to copy the topic and essential question into your header, along with today's date, sub your question column, and your note column, and resume the video when you're ready to begin. So let's go ahead and discuss an example we've already looked at in prior video lessons. A coin toss. So we want to talk about the number of times a flipped coin will land heads up. Well, we've talked about this before, that the theoretical probability of a coin landing heads is 1/2, because there are two possible outcomes, heads and tails, and heads is one of those two possibilities. So the theoretical probability of a coin landing heads is 1/2. So now we want to predict how many times the coin will land heads up in 200 coin flips. You may have a few predictions about this as from prior knowledge, but here is a formula we can use to do that, to make accurate predictions. So we take the theoretical probability and we multiply it by the number of trials, and that will give us an accurate prediction. You might be asking me, what do you mean by trials? Well, trials is just the number of total times we want to conduct the experiment, per se. So here we've said we want to predict how many times the coin will land heads up in 200 coin flips. So the number of trials we're making a prediction for is 200. So go ahead and think about that. If the theoretical probability for landing heads is 1/2, and we want to make a prediction for 200 trials, what would be an accurate prediction? Let's compare. We take 1/2 and we multiply it by 200. Half of 200 is 100. So our prediction, based on the theoretical probability of 200 coin flips, is that 100 of those times it would land heads up. An important thing to note here is that this is not, we could try doing this 200 times, and it may not be exactly 100 times, but it would probably be around 100 times. That is a pretty accurate prediction based on the theoretical probability of a coin landing heads up. So let's try another example. So now let's talk about rolling a die, or sometimes referred to as a number cube in our math problems in class. We want to think about what is the probability, the theoretical probability of rolling a die and getting a 4 or lower. So when I roll one die, what is the theoretical probability that I'll get less than or equal to 4? Let's think about that. What are the total number of outcomes? How many of those are 4 or lower? Let's see if we agree. So I came up with the theoretical probability of rolling a die and getting a 4 or lower as being 4, 6, because there's 6 total outcomes. The number cube is numbered 1 through 6, and all the possible options are 1, 2, 3, and 4. Those would be all the numbers that are 4 or lower. So it would be 4, 6. We've talked about how we want our answers always in simplest terms, and so 4, 6 can be reduced to 2/3, because we can divide 4 and 6 both by 2, and that reduces to 2/3 as an equivalent ratio. And so the theoretical probability of getting less than or equal to 4 when rolling a die is 2/3. So how can we use that to predict how many times we would roll a 4 or lower in 60 die rolls, or dice rolls. So see if you can use the same system that we used up here, the same equation we used up here, to now try it with this next prediction. We are going to again take the theoretical probability and multiply it by the number of trials to get our prediction. So the theoretical probability is 2/3. The number of trials is 60. So what do we get when we take 2/3 times 60? There's a few ways to calculate this. I know a common method is to take 60 divided by 3. 60 divided by 3 is 20. 20 times 2 is 40. So out of 60 dice rolls, we would expect to roll a 4 or lower 40 times out of 60. Notice this is 4, 6, 4, 6. Also equivalent to 2/3. So 2/3 of 60 is 40 times, and that would be a good prediction for the number of times out of 60 dice rolls that we would roll a 4 or lower. Let's try one last example. Now we're thinking about a standard deck of cards, so playing cards with spades, diamonds, clubs, and hearts. And we want to think about drawing a spade from a deck of cards with no jokers. So what is the probability of drawing a spade? Well, a few things you need to know is that there are 52 total cards in a deck, and of those 52, 13 are spades. There's 13 spades, 13 diamonds, 13 clubs, and 13 hearts. And that fraction, 13/52, reduces to 1/4, because you can divide 13 by 13 and get 1, and you can divide 52 by 13 and get 4. So the probability of drawing a spade from a deck of cards with no jokers is 1/4. So now let's see if we can use that to predict how many times you would draw a spade in 1,000 turns. Go ahead and think about that using the model we've done for the last two problems, pausing the video if you need to, and then resuming the video to compare your work with mine. So to calculate this, I again took my theoretical probability of 1/4 in simplest terms. I multiplied it by the number of trials, would be 1,000 times. 1/4 of 1,000 would be 250 times, because 1,000 divided by 4 is 250, times 1 is still 250. So we would expect out of 1,000 turns of drawing a card, and assuming that each time we put the card back, we would draw a spade 250 times. That's going to conclude our video for today. Please be sure to leave room for the summary. Make sure that your notes are complete, and come ready to do more work with using probability to make predictions.